I'm tackling a problem about the ExpSineSquared kernel in scikit-learn's Gaussian process regression. It's used for modeling periodic data, and I need to understand how its parameters affect the model's ability to generalize to new data, avoiding overfitting. I'm using a Gaussian process regressor with an ExpSineSquared kernel to model some periodic data. The kernel uses a length scale parameter, L, controlling smoothness, and a periodicity parameter, P, controlling the frequency of oscillations. My model is overfitting, meaning it's too closely mirroring the training data, including noise, and won't generalize well. I need to find the best way to adjust L and P to reduce overfitting. This problem tests my understanding of how the ExpSineSquared kernel's parameters, length scale, L, and periodicity, P, impact overfitting. The ExpSineSquared kernel is specifically designed for periodic data. We're using the Gaussian process regressor in scikit-learn, a powerful tool for regression tasks which uses the ExpSineSquared kernel for its ability to model periodic data. One option is to increase the length scale, L, while keeping the periodicity, P, unchanged. Another option is to decrease the length scale, L, while keeping the periodicity, P, the same. We can also increase the periodicity, P, while keeping the length scale, L, unchanged. Or, I can decrease the periodicity, P, while leaving the length scale, L, untouched. I'm using a Gaussian process regressor, a powerful machine learning model, with a special kernel called ExpSineSquared. This kernel is perfect for modeling data that shows a repeating pattern, like a wave. The ExpSineSquared kernel has two key parameters, length scale, L, and periodicity, P, which we'll explore. The challenge is to tune the ExpSineSquared kernel's parameters to prevent overfitting. My model is currently overfitting, meaning it's memorizing the training data too well, including noise, leading to poor performance on new data. We are given that the model is overfitting, indicating a need for regularization. Scikit-learn provides the Gaussian process regressor. The ExpSineSquared kernel is specifically designed for periodic data. I can increase the length scale, L, while keeping periodicity, P, the same. This increases the smoothness of the function and reduces overfitting. I can decrease the length scale, L, which makes the model more complex and will worsen the overfitting. I can increase the periodicity, P, possibly improving the model if the current periodicity is underestimated. It's a less reliable method compared to increasing the length scale, L, for overfitting. Decreasing the periodicity, P, is likely to make the overfitting worse, as it introduces higher frequency components. Overfitting happens when the model is too complex and fits the training data too closely, including any noise. This results in poor performance on new, unseen data. The length scale, L, parameter dictates how smooth the function is. A larger L creates a smoother function which generalizes better. A small L creates a wiggly, overfitted function. The periodicity, P, parameter determines the period of the repeating pattern. If P is inaccurate, my model will fit poorly. Getting the periodicity right is crucial for accuracy. I'm tackling a problem using scikit-learn's GAUSSIANPROCESSREGRESSOR with an ExpSineSquared kernel to model data that repeats itself. The kernel has two key parts: the length scale, L, that controls smoothness, and the periodicity, P, which controls how often the data repeats. My model is currently overfitting, meaning it's too closely matching the training data and won't generalize well to new data. I need to figure out how to adjust L and P to fix this. If I increase the length scale, L, while leaving the periodicity, P, unchanged, I'll make the model smoother, reducing its complexity. This is a good strategy to fight overfitting. Conversely, if I decrease the length scale, L, I'll increase model complexity and likely worsen the overfitting. Increasing the periodicity, P, might help if the current periodicity is too short, meaning the model is trying to fit too many cycles. However, this isn't a guaranteed solution for overfitting. Decreasing the periodicity, P, could worsen the overfitting, especially if the data's true periodicity is larger. I'm effectively asking the model to fit a higher frequency that it doesn't need to fit, which can lead to overfitting. The length scale, L, controls how smooth the function is. Think of it as a brush stroke. A larger brush makes a smoother painting, more general, while a tiny brush allows for lots of detail, less general, more prone to mimicking noise. The periodicity, P, parameter sets the frequency of the repeating pattern. If I guess the wrong frequency, the model won't fit the data well. Think of it like trying to match a song's tempo. If I'm off, everything sounds wrong. I'm explaining the parameters of the ExpSineSquared kernel, which is used in Gaussian process regression. It's designed for modeling data with repeating patterns. We'll focus on two key aspects: length scale and periodicity. They control how smooth and how frequently the modeled data repeats. Let's dive in. I see. The length scale controls the smoothness of the function the kernel produces. A larger length scale means the function changes gradually, it's smoother. Think of it like a gentle, rolling hill. A smaller length scale creates a bumpy, wiggly function, like a mountain range. Overfitting happens when we try to fit every little bump. We need smoother functions for better results. The periodicity parameter determines how often the repeating pattern occurs in the data. Think of it like the wavelength of a wave, the distance between two peaks. If I guess the wrong periodicity, the model won't fit the data well. For example, if the data repeats every 10 units, but I tell the model it repeats every 5, it will be off and likely overfit. I suggest increasing the length scale, L, while keeping the periodicity, P, unchanged. This will make the function smoother, thereby reducing overfitting. Think of it as generalizing the data better. If I decrease the length scale, L, while holding the periodicity, P, constant, the function will become wigglier. This will increase overfitting because the model will try to capture even the smallest details of the training data. Not a good idea. Increasing the periodicity, P, while keeping the length scale, L, constant might help reduce overfitting if the periodicity is too small. But it's not always the best approach, because it depends on how accurately my initial guess of the periodicity is. It's a less reliable fix compared to adjusting the length scale. Decreasing the periodicity, P, while keeping the length scale, L, fixed might lead to even worse overfitting. The model might try to fit high-frequency details which are typically noise, thereby leading to a poor fit on new data. This should be avoided. You're working with a gaussianprocessor and an ExpSineSquared kernel to model data that repeats itself. The kernel has two important parts: the length scale, L, and the periodicity, P. Your model's learning the training data too well, it's overfitting. I need to figure out how changing L and P might help. If I increase the length scale, L, while keeping the periodicity, P, the same, I'm making the model smoother. This helps prevent it from fitting noise too closely. Think of it like drawing a curve through points. A larger length scale means I'll draw a smoother curve. Decreasing the length scale, L, makes the model more wiggly and complex, which would make the overfitting worse. I don't want that. Increasing the periodicity, P, might help if the model's current period is too short. It's less effective than increasing the length scale for reducing overfitting, but it's worth considering. Decreasing the periodicity, P, could worsen things. This is especially true if the model is already overfitting, because it might attempt to fit even higher frequency noise. I want to avoid that. The length scale, L, controls how smooth the model's predictions are. A larger L means smoother predictions, better generalization, and less overfitting. The periodicity, P, represents the period of the repeating pattern in data. If I get this wrong, the model won't fit the data well. Increasing the length scale, L, leads to smoother functions and better generalization, less overfitting. Increasing the periodicity, P, might help if the current periodicity is too short. However, it's less directly related to overfitting than L. I see length scale, L, controls how smooth the function appears. A larger L means a smoother function, reducing overfitting because it generalizes better. A smaller L creates a wiggly function, leading to overfitting because it's too focused on the training data's noise. Periodicity, P, determines the repeating pattern in the data. An inaccurate P causes bad results. If P is too small or too large relative to the actual data's pattern, the model struggles to fit the data well. It's like trying to fit a square peg into a round hole. Increasing L while keeping P the same makes the function smoother, directly addressing overfitting. Think of it like smoothing out wrinkles in a picture. It makes it look nicer but keeps the main features intact. I would avoid this. Decreasing L makes the function more wiggly and increases overfitting. That's not what we want when we're trying to fix overfitting. Increasing P might improve the model if the current periodicity is too small. This is less certain than increasing L. It's a good option to consider, but increasing L is a more surefire way to combat overfitting. I wouldn't do this. Decreasing P could make the model worse, possibly increasing overfitting. It's too risky. We need to adjust the length scale, L, and periodicity, P, parameters within the ExpSineSquared kernel to improve the model's generalization and reduce overfitting. Let's tune these parameters to get the best results. The model is overfitting the training data. This means the model learns the training data too well, including the noise, and doesn't generalize well to new data. We are using a Gaussian process regressor, GPR, with an ExpSineSquared kernel to model periodic data. The ExpSineSquared kernel is specifically designed for data with a repeating pattern. GPR itself is a powerful method for regression, and it uses a kernel which captures the relationships between the data points.